Postulates and paragraph proofs. Here's our main ideas and vocab. Okay, a postulate, sometimes referred to as an axiom, is a statement that is accepted as true. So here's 7 basic postulates. So through any 2 points there's exactly one line. Through any 3 points, not on the same line, there's exactly one plane. The line contains at least 2 points. A plane contains at least 3 points not on the same line. If 2 points lie in a plane, then the entire line containing those points lies in the plane. 2 lines intersect, they intersect at a point. 2 planes intersect, the intersection is a line. So it'd be a good idea to put these in your book. So example 1, each of 5 computers, blah, 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 how many connections need to be made? So I have 5 computers. How many connections do I have to make? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you notice, the first reporter had 4, then 3, then 2, then 1. I was done. That's 10. So if I had 7 computers, I would start at 6, plus 5, plus 4, plus 3, plus 2, plus 1. So 11, 15, 16, 17, 18, 19, 20, 21. There's 21 connections. You always start with the number that is 1 less than the number of computers that you have. Okay, so example 2. Determine whether a statement is always, sometimes, or never true. Explain. If points A, B, and C lie in plane M, then they are collinear. That is sometimes true, because I can draw a picture. So here's plane M, there's A, there's B, there's C. So A, B, C, those do not all lie on the same line, so they cannot be collinear. But there is a way to do it. I could draw a picture that has A, B, and C all on the straight line. So that's why it's sometimes true. There's exactly one plane that contains non-collinear points P, Q, and R. That is always true. It's actually one of those postulates. It's 2.4. A plane contains at least 3 points not on the same line. Or through any 3 points not on the same line, there's exactly one plane, which is 2.2. There are at least 2 lines through points M and N. So here's M, here's N. There's only one line. This is never true. 2 points, there's always a line that connects 2 points. Through any 2 points, there's exactly one line. That's 2.1 from the postulates. Okay, once a statement or conjecture has been shown to be true, you can refer to it as a theorem, and you can then use it to justify other things. A proof is an argument that gets you from a given set of information to a conclusion that you want to draw. So the type we'll talk about here is called a paragraph, or an informal proof, where you just kind of write how you get from one thing to the next. So our last example here, given that M is the midpoint of PQ, write a paragraph proof to show that segment PM is congruent to segment MQ. So if M is the midpoint of PQ, then PM is equal to MQ. So that's the definition of the midpoint. If PM is equal to MQ, then segment PM is congruent to segment MQ, and we're done. That's all it took. Because if 2 things are equal, then the segments are congruent. Measures equal equals congruency. So it doesn't necessarily have to be very long. This one actually took me 2 sentences to do, and I was done. And that's the end of the section.